Look, this is going to be a 1 hour kind of a primer on AC, you know, call it an introduction, call it whatever. And to be honest with you, in 1 hour, I just put together enough, tried to, you know, little things here, there, and everything else. 1 hour will be good, you know. You'll walk away learning some stuff, or it'll refresh what you already know. Because I know to truly do an AC course, you know, G and I, we've been popping quite a few, and it's a 2-day courses we've been doing, and they've been going over very, very well. Now, before I get started on this, I'm going to put on a slide real fast up front, okay? And this slide here, there is a scan code, QR code, whatever you guys want to call it. Now, Dorman is having it's called a Rev Up Smarter Solution day. It's on a Saturday, September 20th. And if you could, you really should. I know this is a lot of the trucking guys over here, but, you know, let's face it, electrical is electrical, diagnostics is diagnostics, you know, and a lot of you guys cross over into automotive. You're going to have a hell of a day. You're going to have the best instructors in the country over there. You can see G, Pete Meyer, been around forever, Ken Sanders, and Josh Weaver. And you really need to take advantage of it, you know. And again, you know, hopefully you guys, I'm going to try. I'm not quite sure if I can make it just to sit there. She asked me to come there, you know, because I hope, one of their, you know, kind of instructors, you know, but I'm on the heavy duty end. But I have a little bit of a conflict. My wife's sister passed away, so we're having Friday that day, we're having a little bit of a, whatever you want to call it, but so I'm looking at if I'm going to drive 6-7 hours, I might still do it. I'm going to play it by ear. But anyway, I gave you enough time to QR code it, and if you miss it, there's going to be one more slide on it, so please take advantage of it. So we're not worried about me. Let's get right into this thing. What are we going to cover? We're going to review heating system operations, identify heating system components, review AC system operations, review AC system components, R134A. That's a lot to do, but again, keep it in mind, this is a 1 hour thing. So look, this is heavy duty commercial motor vehicles, and commercial motor vehicles is anything 10,001 pounds over. You know, as you guys know, you guys probably cross over into box trucks, pickup trucks, class 8 tractor trailers, you know, the whole gambit, you know. But one thing is common, they all, like, I should say, the people driving it, like all the creature comforts. And of course, this particular year, that AC is so important, you know. So, but it's those times that you must have a thorough understanding. Again, the idea is, doesn't matter what you're working on, how they operate, types of components, what type of, and there's all sorts of controls out there, electrical, electronic, computer control. You know, and another thing is what is expected from that system, and of course, location of various components, and of course, diagnose them, you know. And I'm going to try to, like I said, keep it simple, again, within an hour range here, you know. But the first area we're going to get into is heating and cooling system, because that really truly is important, you know. I mean, a lot of the systems, you know, for years the trucks have had the shut-off valves too, you know. You got a little bit of a conflict, you know, if you had heat and AC going on same time. So we're, you know, but of course today everything's automatic. But you also have to keep in mind, you know, you get in some vehicles, you're not going to have AC if your engine is overheating. So again, good old, you know, computer control. So let's start from the beginning. You know, here's your typical coolant circuit, okay? And, you know, you see it right on the slide. Heat's created from the engine's power stroke, you know. Operating temperature is reached by restricting coolant flow to the radiator. Engine coolant passes through the radiator tubes and so on. Heat is monitored by sensors in the PCM. The world's changed. But I threw in, regardless of what you guys know or don't know, and a lot of you guys will, you know, a lot of that. So what about air pockets? And I'll tackle that. If you work on any, it doesn't matter, you work on any vehicle, those air pockets can be a killer, especially when you're changing antifreeze. Thank you guys. I didn't mean to bring that up. I just trying to say, I was looking on the chats. Thank you so much. I was truly want to get, you know, down to a Chi, so I'm still playing around with that, you know. But anyway, with engine coolant, you know, when you change those coolants, antifreeze, you got to get those air pockets out there, and that's nothing new. That's been happening for years and years and years. So keep that in mind. You know, the other thing that's changed too is, unfortunately, you know, what do you put in that vehicle? What kind of coolant do you put in there? I mean, there's you name it. You know, if you're working with Euros, if we're working with whatever, different OEMs, you know, I mean, you have a choice of antifreezes that are unbelievable. You know, can we mix green, orange, yellow? Those questions always come up. You know, do we need specific gravity, fractometers? I have those things. Okay, so instead of getting into a debate that, you know, you should have this, you should do this, the bottom line is following manufacturer's recommendations, okay? And this is important too. You know, why do we have that little bit of mixed antifreeze coolant? Again, you can't get any simpler than this. Antifreeze lowers the freezing point and raises boiling point of engine coolant. And of course, so does pressures. That's why you have high pressures, caps and everything else, and you'll see almost a relationship with the AC systems. But anyway, must be mixed with water in correct ratio, provide the best combination. You know, now in my shop, and every time we do that, you know, we do the AC, when I do it with G, we ask the questions, what do you guys get? And I like my pre-mixed 50-50 already. That takes the guesswork right out of it, you know, but you need to be precise. And so many places I've shops, you know, the guys from different shops and fleets, they do the same thing. They'll get the 55-gallon drums. They're pre-mixed, especially, you know, we're pretty lucky, you know, probably get away with just a couple of different types, you know, your global and universal and stuff, so. And again, I already mentioned use of a bleeding funnel should be used. And those of you that work on some of this stuff, you know, throughout the ages, Caterpillar, for example, had a very, very specific way of, you know, trying to get the air out there. And if you screw up, you know, you'll pay the price. You know, Cummins has a timeline of how you do that bleeding of the air out of it. So it can get quite complicated. It's not really complicated as long as you follow the instructions. You'll be doing good, you know. So anyway, the other thing is, as long as we're talking about the cooling of the engine, you know, keep it all cool and everything, we have to discuss the coolant fans, you know, and of course, you know, everybody has a different way of calling it or whatever. I'm so used to calling it strictly a clutch fan, period. You know, I'm comfortable, been doing that for the last 60, 70 years, you know. But they do come in different styles of engaging them. You know, we got the viscous type, air applied, you know, the air applied disengage is the most popular for our heavier stuff. But don't forget, you have viscous type, you know, when you get into the smaller trucks and especially pickup trucks and so on, okay? And not to mention too, you know, when you get into some of these controllers today, you know, climate control tied with your body controllers and so on, they're usually tied in with the AC system, you know. I mean, you can see it when you hook up the pressure gauges. If initially you are able to get your AC to come on, and then all of a sudden your clutch fan isn't coming on, boy, you watch your pressure gauges. I mean, they're going to rise right up, you know. So there's a huge interrelationship between the coolant fans, the clutch fans, all day long, you know. And of course, I'm preaching to choirs. It's nothing worse than, you know, clutch fan isn't coming on, or the clutch fan is always on. You know, those are the complaints we get, you know, with the heavy duty trucks, you know. So typical, just so you know, we'll pick on the viscous. The typical fan speed below 150 degrees is 1000 RPM, above 160 speed increase. How does it work? It has a kind of built-in thermostatically control that controls the clutch, you know, that it will disengage the fan when less cooling is required, you know. So again, it's temperature related, you know, thermostatically controlled, you know. And those of you that work on these stuff too, if the first time you ever get onto these, you're trying to get that clutch fan off of there, off the hub and everything, and you got your huge big wide wrench on it, and it ain't turning. You know, chances are, you know, it's it's left-hand thread, not a right-hand thread. So, you know, those are all things that you learn after a while. These fans are located either in front or behind a radiator. You know, typically they're, depending on how you look at it, wind up being, you know, between the radiator and the engine, you know, usually inside a shroud. They may operate at 1 speed, 2 speed, you know, again, depending on the vehicle that you work on, you know. And the electric fans, motors, switch on and off depending on coolant temperature, you know, so they're temperature controlled. Fan electrical circuits usually triggered by a signal from the coolant sensor, you know. And in my electrical class, I love this these radiators because I can now walk through with you know, ground control circuits, what turns these on, and so on and so on. So it winds up being a good learning curve also. Eh? The other thing too, of course, and you know, shut that vehicle off. But I know I got a Ford with the shutters in front, and boy, I gotta tell you, lately that thing is so loud when I go over someplace and stop someplace. I mean, those fans are screaming, you know. And of course, I'll always get some wise guy coming up to me, you know, your fan or something is noisy in there. Yep, thank you, sir. Appreciate that. Didn't realize it, you know. So, but again, those are the things you deal with. So, air distribution. Now, this is common, doesn't matter if you're working on a car or pickup truck or whatever, okay? That air, okay, that you're circulating through the cab, okay, it's not like the good old days when I first started. I had a little cable that I would pull in a box on an old Mac, and I would flip the door open and everything else. Everything has gone into, you know, let's keep it convenient for the driver, you know. So this is where we're at now. You know, mechanical, vacuum, electrically operated, usually depending on the size of truck, type of engine. And basically it allows the driver to regulate temperature, intensity, select the air distribution, or change the blower motor. And typically there are only 3 basic types that you're going to run across. They're either mechanical, vacuum, although some may have a combination mechanical, vacuum, and electrical functions and stuff. And speaking of modes, and because we're going to get into the air distribution, as a rule, you know, what is the default mode on most of these? If anybody can kind of type in the chat, you know, and type in the right defrost, absolutely, just very, very good, you know. And defrost is good. That's a good answer, because let's just think about that. Okay, what are we trying to do with that air in the cabin? We're trying to, think of the word, condition that air. So boy, that means trying to get moisture out of there. And the worst thing you can have is have that moisture on the windshield when you're going down the road. So yeah, absolutely. Very good, guys. Very, very good. Why are you guys watching? You got all the answers already here. Just kidding. Keep watching. Sorry. Yeah. The amount of outside air passes through the heater core is determined by the position of the intake air door. Flow of air always goes through the evaporator first to dry the air before going through the heater core. And again, there it is, dry the air before going through the heater core. Air mix blend door combines outside heater core air in order to adjust the temperature to that determined by the driver. So So we've come a long way with distributing this air. I mean, let's face it. If you guys have vans, you got air distribution to the back of your vehicle and everything else. So I mean, no more of trying to open the windows, going down the road 55 miles an hour, and there's my cool air. So you don't have to do that anymore. In case you guys are wondering. Air distribution system directs airflow in defrost, vent, floor modes, controls heat intensity and cooling, and regulates the rate of airflow with different blower motor speeds. Air distribution components are commonly placed inside a single housing. Let me ask another question. It's not the answers we need now, it is the questions. All right. Okay, Harley, for you. We're talking about air conditioning now, Harley, you're all right. We're talking about air conditioning now, and we're talking about motor speeds. What truly is the best speed to condition the air in that vehicle? Anybody, write it out. Low. Man, that was fast. Damn. Okay, low is, why? Well, that's the next question. Why is low the best? A little slow draw here. Absolutely. Gives time for air to condition. Okay? Beautiful. Lot time to absorb heat. Absolutely. Wow, you guys are smart. Makes me feel kind of foolish up here. The amount of outside air that passes through the heater core is determined by the position of the intake air doors. Flow of air always goes through the evaporator first. Excuse the misspelling there. In the evaporator first to dry the air before going through the heater core. The air mix, the blend doors, combines the outside and heater core air in order to adjust the temperature to that determined by the driver's control. Lucky drivers be able to do all that. I'm just kidding. Right now, to be honest with you, when I get done at the end of the day, I'm so glad I'm able to just flip a freaking switch and have that air conditioning on going home. I hope I didn't miss anything. All right. Now, again, we're trying to do a lot here. Okay. Refrigerant, on the other hand, changes from a liquid to a vapor, and I know in a 2-day class there'll be a little bit of a different transition. But one of the things with air conditioning is having a good understanding, and I call it the change of state. Okay. We all know about solid, liquid, and vapors and so on. And truly, that's basically, we're using the liquid and vapor change of states. That really is your air conditioning. Okay? So we're trying to change from a liquid to a vapor and back to a liquid again as it circulates through the AC system. It takes a journey. The refrigerant changes of state, absorbs and releases more heat energy than it would if it were always a vapor, always a liquid. Okay? And in that little box over there, you'll see, talk about latent heat, and everything's really gauged to British thermal units, 970 PTUs latent heat. And basically, if you look at that, water boils at 212 degrees, but if we want to change state, you're going to have to add that, BTUs, that extra BTUs. And that's when you change the state of going to vapor. And by the way, if you were to use a temp or something on that water, the water still will reach 212 degrees, So now, let's real world. Guys, this is our world, okay? Here's an M2 blend door gear strip, and you guys go through all that, and of course, this happened in wintertime. The temporary fix make it through winter with just heat, just to keep, typical fleet. I need the truck. Now the fun begins. Now you actually got to do the fix. This one actually wasn't like bits and pieces of parts you can do. Dash needs to come out of the way. So if you're gonna do that kind of stuff, make sure if your diagnostics first, because this is not a 1 hour job, you know, despite what somebody say, oh, can't you get it done in an hour? Yeah, right. Here's my wrenches, you go for it, you know. This is what you're trying to reach, get out and switch, complete unit, blend doors, blower motor, door actuated condenser. It's like, hey, I didn't create the problems, you know, so do you want to do that? You know, I'm here. I'll fix it, I'll do whatever, but you have to pay the price. Sorry about that. As close up of blend doors, and really if you look at that, you know, when you see all the doors and, you know, the way they work, it doesn't matter regardless of size vehicle and so on. They typically they kind of work similarly, you know. You got gearing, especially when you get computer controlled, you got electronics, and you know, you got electrical motors that'll do it. Now as long as I had that out, I figured I might as well take some pictures here. You know, again, try to do something as quick as possible, you know. So this is the firewall side inside the engine compartment, you know. And I put some little side notes figuring, you know, again, you know, we have guys here that, you know, watch this. This might be their first exposure. These are guys, and I appreciate the guys that have been doing it for years. And by the looks of it, they're, you know, they're really got their... they got everything together. They know exactly what they're doing. I really appreciate the mix of crowds. But here we have, you know, of course, remember it's an air box, so you got the coolant has to go through it. You got the heater core in there, you know. And if you notice here, there's an expansion valve. Let's see if my thing works here. You know, we've got the expansion valve over here, you know. It's kind of a block design, I call it. There's a needle in there, and that needle, that's a restriction, okay? And basically what that does, it restricts refrigerant flow. So it's a restriction orifice that sits between the high side, and that's a split. And we'll get into that a little bit, you know. You got a high and low side of the refrigerant system. So the restriction of flow of a closed system creates, and that's the whole idea, trying to create a pressure differential between the two sides of the orifice. You know, it's just like pulling your water nozzle, you know. I mean, you make a difference, you know, do I have more pressure coming out, less, and so on. And always keep in mind that there is a pressure and temperature sensing device external, you know, but there is a relationship between pressures and temperatures, okay? And typically you have other ones that have a capillary tube, and, you know, so they do come somewhat in different configurations, okay? The expansion valve, a little better, you know, explanation. Movement of refrigerant with the expansion valve orifice restricting its flow creates the high side and low side. And basically a small amount of high pressure refrigerant passes through the orifice in the expansion valve, and as it reaches the low pressure in the evaporator, refrigerant pressure drops. So again, we have the pressure temperature relationship, okay? How much information can you get from this tag? And that's kind of important, guys, you know, because especially humidity, good point, okay? Humidity does make a huge difference, absolutely. There's a sun load, heat load, and you years ago, just think about, you know, even the sun loads and stuff, you know, everything plays a role in this. So how much information can you get? Because absolutely, you know, sometimes, you know, that information is the most important thing when you're working on AC. You know, high pressure warning, of course, on this one. Type of refrigerant, absolutely. Required amount of, that's crucial. The required amount of refrigerant is crucial, okay? Required type of oil, absolutely, okay? You need that information for diagnostics. You know, type of oil, you know, everybody says PAG oil, but keep in mind too, there's different weights of PAG oil then too, so you can't just do the universal thing anymore. So especially if you're changing compressors and stuff, you got to be careful. Yeah. So moving on, like I said, in a 2-day course, you know, absolutely we slow it down, you know, and cover much more. But I figured, you know, just to get a lunch and learn, we'll get a few things. So of course, if you got a machine, you got a storage tank, that winds up being important. And this is the one over here, you know. the disposal one, man, I just ordered about, we just got about 10 more of these. I mean, when I'm telling you, it's a hot summer. Plus also, I can't remember, G and I were talking about, I think it was like $400 some a can. I mean, this is quite a change from quite a few years ago. And of course, that has to do with the phase in with 1234, so the sooner they get us off of this one, that's the government ways, I guess, to get us off of this 134A, but I'm not right now going to get into all that stuff. But, however, when they do empty out and stuff, there are requirements that you have to do. It must be sucked down to a vacuum, punch a hole in the tab, and word empty must be marked on two sides of the tank, so. Non-condensable air, that is a huge issue. Okay, they raise the temperature, system pressures, they reduce cooling. Cause compressor to cycle rapidly, may result in evaporator freeze-ups, So here's a device, relatively inexpensive, attaches to your refrigerant supply, see if you got how much, if you got that non-condensable air. How do we get rid of it? Opening the valve on a manual machine, remove the air until the gauge equals ambient. And my older machine, that I had, I had to hit a purge and everything else. And the new Robinson I got now, it takes care of it. The new machines, I got to tell you, they're pretty, wow. They take a lot of the guesswork out of it. Let's put it this way, So you just gotta get comfortable with the buttonology, So but they work pretty well. And of course, here's an example, just a machine, and I don't know what you guys have, But keep in mind too, reason the pictures there on the vacuum pump oil, you really should, those machines are very, very expensive. And you actually should replace that oil once in a while. Check it, make sure you put the right amount of oil in. I mean, this type of weather over here, these machines were crazy. The on time with these pumps is unbelievable. Of course, if you notice, and not sure who has what machines, refrigerant identifiers, absolutely. Very, very important. So, because Gino, you're absolutely right. Because one of the things we don't know, we're assuming we're getting the refrigerant from very, very, very good sources. But then again, you don't know who worked on it last, who did what, where did they get the refrigerant from, did anybody mix the stuff, and so on and so on. And again, you got to protect your machine. Okay? But regardless, if you have these machines, a lot of them very sensitive, it'll tell you, the prompt will tell you, don't touch it, as it's going through all that stages and stuff. So something tells me, not that I'm a, rocket scientist or anything, but something inside my head says, oh, wow, there's got to be some huge, very crazy calibration going on in here, So calibration is important, And one of the things you can do is that is where you see this 33 pennies is 3 ounces. If you ever have any doubts, is it calibrated correctly and stuff? How do you know? You just add the 3 ounces to it, put it on scale and see if it comes up with a 3 ounce more. If it doesn't, then you're going to have to adjust it. But I think that's a real nice thing to do, Oh yeah, Harley, you're right. I keep forgetting about the do-it-yourselves. Oh yeah, you know what? I don't want to spend that money out there. Oh, Mike too, absolutely. And I don't get it where these guys go up into the stores and it's like, oh yeah, I'll fix my AC. I'll get some sealant in there. Really? Then it goes through your machine. So flushing the hoses. I hope I had the slide on coming up too. Just to keep in mind, if the next vehicle to be serviced contains a different type of oil, then the previous vehicle service hose must be flushed of all residual oil, prevent contamination, you know. And again, it's buttonology, depending on your specific machine. In this particular case, press the menu button on the keypad, press the up or down to scroll hose flush, and press start yes, you know. So every machine, today's machines are pretty good with that, you know. We've come a long, long way. And I'll get my little head out of the way over here. Yeah, so connect the hoses to the Oun storage port connections, coupler valves, select start, yes, begin the flush, okay, and of course it's buttonology, flush complete, and so on, you know. So again, you need to read the directions of your own particular machine, okay. Well, that's a good point too. Commercial HVAC equipment from field place. Yeah, absolutely. You know, we get a lot of the commercial people, they have extra vacuum pumps and so on. You know, very, very fast doing a lot of stuff, you know. The only thing you got to watch is, you know, going through the recovery and stuff. They're very specific with, you know, as per EPA, you know, the machine has to be for 134, 1234, and so on, you know. Refrigerant identification procedure, I got to tell you, you know, this is a perfect example of the sealant issues. I'm going to switch over here a second here. I'm going to flip this. So what I have over here, I have this. If I have any doubts and I want to make sure, and I know this, you know, I'm having my doubts. I don't know who the hell, and especially if the customer says, "Oh yeah, I tried," you know, yeah, right. I tried some sealant in there. Oh, you did? Okay, then I'll take that extra step, you know, and it's basically a float, you know, and it has these little kind of boy, I'm having a hard time. They're little capsules and you fill them with water and stuff, you know. And then basically what happens is you inject those capsules with this thing over here. Little syringe, you know. It's only for that, guys. It's not for cooking or anything. Yeah. And then basically you draw some out and, you know, you got a little scale over here and you look and compare percentages. You know, but the bottom line is you got to do whatever you got to do to protect your machine, and it's huge. Okay, I can't remember if I had the Aircept. I'm pretty sure that's basically what you're looking at. You know, suspect sealant. You know. And again, if somebody did that, let me tell you, I have no qualms in, you know, telling the customer we're going to have some issues. Don't, you know, if I get into it, you know, there might be definitely some extra expenses. Why should I be eating something that's not my problem? You know, you as a do-it-yourselfer, didn't you think ahead of time what you were trying to do? You know. Oh, this one here, I didn't bring my machine in. It's got it on the machine. This right here from Aircept, it is awesome. G hooked me up onto that, you know, and I have it on the machine. It stays on the machine, okay, and basically, okay, it is a sealant remover. It's not, if you have a machine, you really need to go out and get it. The only thing is that, you know, you got to watch. You got to flip a switch over here. You know, it's a recover, and then in the vacuum is where you do your recharge. But it'll make sense. But anyway, those hoses, okay, they'll make you reach anywhere you want because you're basically coupling up to still your AC. You know, but it works great. I mean, it is. I'm so glad I got that one. You know. Customers, oh really? Customers, yeah, that's right. Hey, maybe we can make the customer sign an affidavit, you know, and then go back after them. I like that. Customers never going to, you're right, not to get away from the subject, but customers have this they're kind of a little bit funny. they don't want to divulge as much as they think, because they think the more information they give you, the more it's going to cost them, instead of that the more information you give me, it'll be less pain for you, you know. Absolutely, you know, good stuff. Thank you, guys. Now, the AC connections, they're kind of like, I shouldn't say stupidly simple, but you know, it does help if the connections are clean and stuff, trying to get the coupler to clip on and everything, you know. And if this is their first time on, you know, you're here watching it because you're thinking about getting AC, you know, it's fairly straightforward, you know. And basically what you're trying to do is you couple it on, but you really haven't make the actual refrigerant connection to make it flow. You got to hit that thumb on top over here, you know, whether it be the high side or this is the low side, you know. You got to turn that in. In means now you open it actually up, you know, so it's opposite of, you know, what you might think on a faucet, eh? And of course, if you turn it out, now you actually close it. So, you know, it's one of those mindsets, you know. Gerald, yeah, absolutely is money well spent. Thank you. And of course, leak detection is another huge thing. There's so many things out there, you know, but if you use dyes, the dyes, we can get in this whole subject with dyes, that light is, you know, what it picks up. You gotta really make sure that you get the right light and everything to detect everything. And of course, you got the electrical leak detectors out there, and you'll see down there with a bullseye. So all that stuff is out there, you know. And leak detection is, it is kind of, it's an art in itself. It's a skill set. So for example, if you have electrical, you know, electronic type, you got to go very, very slow with that, you know. And the refrigerant, the vapors are heavier than air, so usually you got to try to get it underneath the fittings and everything, you know. So, you know, and they're a little bit hard, you know. So, but you got to identify the leak. You can't just take it out, you know, put some in, let it rip, and a week later it's right back, you know. Again, it's in there for a reason. And of course, sometimes we get lucky. You know, you still can't beat a good visual if it's possible, you know. So, yeah. And of course, common leak sources right there. Yeah, your cap, your primary seal is a cap. You got the little rubber in there, but don't forget, you know, how good is it sealed? You know, even the Schrader valves, believe it or not, that you go in there, you got to be careful. There is such a thing as under tightening and over tightening, you know. Oh, that's a very good point, Chris. Vehicle, you're right. Vehicle was purchased used. Sealer may have been used prior to that. Yeah, that makes sense. I mean, just think about it. If somebody's trying to sell a used vehicle, you're absolutely right. You know, it's like, I'm going to do everything. I mean, I want to sell my vehicle. You know, the hell does the next guy know? You know, as long as the AC works, they're going to be happy, you know. Nice. Usually won't get it all if the vehicle has a heat exchange. Certainly will need to replace it. Oh yeah, receiver dryers and stuff. I got to tell you, all day long, if I get into compressors and stuff, that thing is, you know, they're not pricey at all. They're out of there, you know, because the receiver dryer also supposed to take the moisture out of there. You got that little bag in there and stuff. So I mean, let's face it, some stuff you got to include in the price of an air conditioning job. Now, how does the system works? Okay. So here we have a system over here. It is a closed loop system. And if you start, you know, depends on where you start, okay? You know, we're going in direction over here. You know, we do have a high and low side, but here's your compressor, you know, receiver dryer, expansion valve, you know. So basically what happens is, you know, into the evaporator, you're going to have low pressure liquid. And what's going to happen is that low pressure liquid is going to take on cabin heat. And remember we talked about the change of state? It's going to change it to low pressure vapor I did say low pressure liquid goes in the evaporator, but it's going to change to low pressure vapor, and that's going to get kind of sucked into the compressor, okay? And compressor pushes out high pressure to vapor, and that's going to go, of course, to condenser. At the condenser, you're going to have that rush of outside air that's going to remove the heat from the refrigerant, of course, I'm talking about. And it changes to low pressure vapor. Then you got the receiver dryer receives this warm vapor and liquid, and the expansion valve receives warm liquid and dispenses cold liquid. And of course, the journey begins again. It's basically, look at it like a freight train. It's going to go, get that warm air, and that has to do with, second law of thermodynamics. Anybody know what the second law of thermodynamics is? Heat goes which direction? Typical AC system, purpose is to absorb heat. Again, showing me a different version, remember? Showed you over there, you got the expansion valve that seems to be the most typical ones that we have in trucks with the receiver dryer. The receiver dryer, there's your condenser, So again, now that I talked about it, what goes into the evaporator? Is it vapor? Is it liquid? Is it high? Is it low? And of course, we know that compressors definitely want to see some vapor. That much we know, because that compressor, you start, compressing liquid, you're going to have some huge issues. And by the way, the compressor works almost just like your air compressor that you have in your vehicles. Again, you're trying to absorb the heat, transport it to the condenser, where the heat is then transferred to surrounding air. Again, our job is to test the system for proper refrigerant pressures, for refrigerant leaks, for heat transfer. And that's what we're basically trying to do. You know how the system works? Is it working the way it's supposed to? And of course, if we're going to do that, you're going to need manifold gauges, thermometers, scan tools, volt ohm meters, Again, we're into electronics. The expansion valve, I briefly had a little bit on that. Expansion valve sprays refrigerant into low pressure liquid spray at the evaporator inlet. Amount of refrigerant entering the evaporator determined by the there's again the temperature pressure relationship. Sensing bulb at the evaporator outlet tube. Okay, so you got different ways of getting that temperature. What should my gauge read? 15, 30, this isn't cast in stone. You need to actually get into some real good books and stuff. Refrigerant travels through the evaporator cores, absorbs the heat. In the process, changes from a liquid mist to a vapor. Change of state allows to absorb a great deal of heat energy without corresponding. So listen, let me back up here. Amount of refrigerant determined by the temperature sensing bulb. Okay, so for this heat from the cab, what's important with an evaporator? I got fins in there, don't I? So the evaporator has to definitely get that airflow. How about on the condenser side? If I want to get rid of the heat, right, the condenser has to do what? Heat goes to where there is less heat. No such thing as cold. Absolute absence of heat. Ice cubes don't make your arm cold. Heat from your arm go very, very, very good. Like I said, you guys are good. Damn. System comes empty, replace RD or accumulator, quality, yeah. Okay, absolutely. Very good stuff. Very good stuff. Actually, we should make this a whole day thing here instead of a just 1 hour thing. I'm trying to buzz through here real fast. But anyway, my point being is that airflow goes along with that refrigerant flow. Okay. And then refrigerator returns to compressor, it's sucked in and compressed into a high pressure gas. High pressure gas enters the condenser, which is similar to the radiator design. So as the refrigerant passes through a condenser, it condenses high pressure liquid. Change of state, again I mentioned right from the very first slide, change of state, change of state, change of state, releases heat energy greater than its change in temperature. High pressure liquid then travels to a restriction, a high pressure line. You got a fixed orifice or expansion valve creates restriction, and it's going to cause a pressure drop. Refrigerant changes from a liquid to a liquid mist, enters the evaporator, where the entire process, it starts repeating all over again. What a wonderful machine this is to keep us all cool, keep that air conditioned, less humidity and all that stuff, And of course, if you really get into it, I don't have time to spend here right now, but you get into any good publications and stuff, you're gonna, this helps you out with your pressure readings and so on and so on. Where again, temperature pressure is huge, Expansion valve. This valve will close once the sensing bulb capillary tube has detected temperature of the evaporator is becoming too cold. And why are we concerned with the evaporator temperature? Freeze up. Absolutely. Remember I said that, you need flow going through there. And of course, those of you that have changed evaporators, you've pulled them out with all sorts of crap and everything on it. Some little bit of misty oil that gathers every dirt and dust and everything else. Well, guess what? That freeze up and ice would be the same thing. So we're trying to maintain those, to prevent the evaporator from freezing. Very good, Harley, very good. Will this chat discussions be recorded for review? That's a very good question, That's why I watch my language, that, makes it, just kidding, but that's a good question. I'm not sure if the chat portion is recorded. I mean, well, I'm trying to read the chats if I can, so that part, I guess, will be, If the valve sticks closed, no refrigerant can enter the evaporator and so on. So, valve sticks open, too much liquid refrigerant enters the evaporator. You're going to have not have the most effective cooling, And of course, the relationship, like I said again, is high side pressure drops. And again, if you happen to have the sensing bulb, it's got to be secured to the correct location and so on. Some vehicles damage missing wrapping material, thick black tape, must be repaired or replaced, What caused the valve to open? Valve will open once the sensing bulb capillary tube has detected evaporator is beginning to warm up back again. Again, opening a valve more increases refrigerant flow into the evaporator. That increases cooling. Look, guys, I'm going very, very fast because I'm on a time constraint. But speaking of, will this be recorded and so on and so on, I believe there's a handout goes along with this, so you can always sit back and go through it a little bit slower. And again, there is a direction. I just did that the other day just to kind of put it in PowerPoint here. Evaporator, condenser, liquid from condenser to evaporator. And there's the fixed orifice tube, expansion valves, restrictions, flow refrigerant. And again, you're trying to do a separate. The fixed orifice tube, as its name implies, has a calibrated restriction that does not change. Versus your expansion valve. Are all these tubes the same? Which way is the correct way to install this? I mean, we can spend quite a bit of time if you happen to run into vehicles with orifice tubes. They're a pain in the neck to get out, and the best ones to get, of course, are actually the variable orifice tubes. So you latch onto those; they work very, very good. Here it is, variable orifice tubes can be found on new vehicles. A little bit more expensive, but it's worth replacing any regular orifice tube with this variable tube, So kind of like trying to mimic the expansion valve, somewhat, not the same though. Right? And these improvements will result from installing this tube. You've got cooler duct temperatures, lower gauge pressures. System will cycle compressor on and off, and that's the other big thing with that, to prevent the evaporator from freezing. So that's another way to prevent the evaporator from freezing. So and you can hear the clutch cycling and so on. Okay. What commonly occurs whenever we have debris in the system, it'll have a tendency to collect at the screen of the orifice tube. Remember this especially when we have a component failure such as AC compressor. So, you know, definitely, absolutely, that trapped stuff will definitely, you know, wreak havoc on everything. Test the system with manifold gauges, AC machine with a compressor engaged. You know, you got some normal readings. You're using R12, and you're using R134 depending on it. But you know, reason you got R12 in there too is, you know, for years and years, this is nothing new. I grew up with all the changes of retrofit and everything. So, you know, the R12 is a good comparison, and the reason you see that as a good comparison is one of the big worries was when we retrofitted to 134, are we going to have the same pressures, and what are we doing with, you know? And again, outside temperature will definitely affect all that stuff. What should I be aware of? Remember that this tube can be installed in different ways, you know, so it's a good slide on there, you know. Now, not all things are about refrigerant leaks, okay? This is a 2009 International Hard. We just had it in, I think, a month ago. It's a construction type of a truck. It's got attenuators on and everything else, so it does a lot of sitting around and all that stuff. But it did come in with a code for motor actuation, you know, so hey, not getting, driver was complaining, oh my gosh, you know, it's hot and everything else. Probably in a cold winter, nobody really cares, but weather changed. So the motor broken. The code caused controller to not control hot-cold blend door. Well, of course, what do? You replace the motor. Okay? And of course, cleared the code. Clearing the code now switches from hot to cold. But, still no AC. No power to compressor due to open thermistor. So now we got in electrical. Started with some little bit of a mechanical issues with the doors. Okay. Now, change the thermistors. Now the compressor was turning on. But, not as cold as it should be. So we checked the charge. Oh, wow. Vehicle that old, charge was there. Everything was still fine, you know. So it's like, wow, where are we going with this thing? Eh? Remember we talked about the evaporator? We were lucky we were able to reach it, okay? Because guy needed the truck fast. It's one of these construction season. How fast can you get this out? Gently clean it with a brush, foaming coil cleaner. You don't want to damage those fins and stuff. Everything you do is gentle. Eh? What could have prevented some of these issues? Guys, you cannot beat preventive maintenance, because somebody will say, well, preventive maintenance, there's nothing to grease, there's nothing to do, you know, especially if this is a commercial motor vehicle crowd. First thing comes into your mind, you know, change oil, do this, do that. Well, what do you periodically change the oil on the AC system, or, you know, just change refrigerant in there? You know, what are you going to grease? You know, shaft on the compressor? No. Back to the basics. Okay. Wonder how long the cabin air filter has been missing. Oh, really? There's a truck with a cabin air filter? Most of you guys with your cars and stuff, you know you got it in there. Install the new filter, totally happy driver. Eh? Actually, we got a little time for questions. I want to hang loose. Let me do something. Another tool, as long as we're here. And again, try to do a lot within an hour, okay? This is a diagnostic flow, glass flow thing, okay? This works great, you know. The guys are always impressed when G and I do the 2-day classes and everything. We use it all the time, you know. So basically, what happens is you hook this up. You put this in a vacuum first, by the way. Then you hook it up, and then you open up the high pressure. And, you know, with the vehicle running, you slowly turn the low on, okay? And you'll actually see. Do you guys remember, ever when you started years ago, you used the clear tubes for fuel just to see am I getting air in the fuel and all that stuff and everything? Kind of a similar concept. And then you can actually see, man, look at this. I got a lot of debris coming in. I got a lot of stuff going in. I actually hang loose. Let me. Well, it's hard to see, but if you zoom in on this, okay, and that's another AirSep product, by the way, okay, and this is the expected colors and stuff. It's a diagnostic site class, visual reference, oil, refrigerant, unknown substances floating in fluid, so that is another tool that is well worthwhile trying to get into it. Sorry, sweet Doreen, I need to leave this. Harley, it's been a pleasure. It really is. I enjoy, having you on every single one, And the site class also shows bubbles. So I'll watch the chat, but I want to remind you guys again one more thing. This is the earliest I've been able to get done over here. Wow. This is because I got to work too, so I know G's got his plate full over there, and so does Doreen. But let me put this on one more time. Again, take a picture of this, take a snapshot of this, and, try to make it if you can. I mean, it's a nice little, well, some of you guys have to go a long way, but if you're within that area, within that Philadelphia area and so on, if you're in the East Coast and everything, it's well worth going down there, I mean, again, I gotta tell you, when you see these instructors, Pete Meyer, Ken Sanders, Josh Weaver, if I had half the freaking brains they do, wow, I'd probably be doing something else besides what I'm doing here, You're gonna get the best information. I mean, you got a wealth of knowledge going in there. So take a minute out, guys, and try to take that picture if you could, please. Okay? So, and again, here's a little bit of thank you. If you scan those, there's a survey, and so on, So try to go doing with that. I didn't get into time really. Time flies away. I didn't get into because it's a heat and temperature thing. Chino is on, so I want to mention it 1 second. Because for years we talked about temperature, and I think I'm going to wind up doing part 2 anyway. But we did temperature, touching, and feeling stuff. He sent me a little email the other day. One thing I'd like to share with you if you're interested, during the recovery period, I like to run my hands over as many components as possible. All components should be equally cold during this procedure. If I come across something that isn't cold, sometimes that's a potential problem. On occasion, I'll use a thermal imager instead on hard to reach components like a condenser or something, So this is really, really good feedback, I mean, Gino's one of the guys we always text back and forth, but let's see if I get another part 2 coming, heading a little bit more with diagnostics, maybe a little bit about the compressor. So I'm gonna watch, so you guys can leave anytime you want. I'm just looking at the chats, post a handout, let me know if you can download, okay? Thank you, sweet. Thank you. Very, no, it's, you guys keep throwing the thank yous and stuff out there, and I truly appreciate it, but I'll be very honest with you. I can't do it without you guys. I mean, if you guys aren't coming on all the time, Mr. Jim Wilson, we go back a long way too, So another great instructor. But anyway, we're, again, can't do it without you guys, and I do truly appreciate the feedback, so so anytime, Doreen, you think you need to go, I guess we can call it.
got another minute.
Oh yeah, awesome, awesome. I'm enjoying watching the chat. I'll be very honest with you. You know, this is like, oh, thanks, Squid. That's Clint. That's my son. You know, just nobody. Yeah, nobody. I've had customers come in. Is Squid around? Swede around? You know, I got one of those funny names. You know, refresher. And that's why I said, even you know, we all, I'm the same way. You know, I don't know everything, and I probably forgot a lot. So it's, you know, it's great. You know. Looking forward to part 2. I think we might do part 2. Absolutely. You know, I've been promising so many part 2s of everything we're doing. So, I guess I better hang around a while, huh? Oh, nice. Well, anyway, I hope you guys make it through this very hot summer, and you know, try to stay cool. You know, it's very important for your health. You know what you got to do. You know, your health is more important. So, I mean, give a good day's work, but, you know, do it correctly and wisely, and, you know, I think everybody will be fine. You know, New Mexico, perfect, beautiful. You know. I like that. My summer's going to be a lot cooler now. Time to fix some AC. You know. Even if you don't have AC in wherever you live, you know, hop in your vehicle. Now you know how to fix your vehicle's AC. You know. Oh, beautiful. Gerald's sending some cool temperatures our way. I don't know how you're going to do it, buddy, but I truly appreciate that. You know. Even got a crossover from automotive. That's beautiful. I mean, not to be a wise guy, but that's why I mentioned that event coming up in Philadelphia with G and the other trainers. You know, even if you're in trucking, you're gonna get so much out of it. You know, those guys are gonna give you so much. I hope they fill the halls. You know, that they get overbooked. You know, so but they know how to handle that. You know, so. But I guess we're done now, so thank you guys. Really appreciate that. All right, take care.